Hello and welcome, dear lovely students. I hope you're all doing great. Today we have a new subject in chapter 1, section 3, simplifying square root expressions, page 12. In the previous class, we discussed square roots and perfect squares. Right now we have simplifying square root expressions. In this section, what is important is adding and subtracting square roots. When you want to add or subtract square roots, there is an important rule you have to know. It says when we add or subtract square root expressions, the radicand must be the same. What does it mean? It means when you have two square roots, okay, you want to, let's say, add or subtract, let's say plus it or minus it, the rule is the radicands, the number that we have here, they must be the same. For example, if we have 5, square root of 5, then we have to have the square root of 5, then we can add it. For example, 3 square root of 5 plus 2 square root of 5. Okay, how to add it? Because they have the same radicand. Okay, write down square root of 5. We keep the square roots, we do not add them. Okay, then what shall we do? We are going to add those numbers that we have in front of the square root, the coefficients. So 3 plus 2, it's going to be 5. So square root of 3 square root of 5 plus 2 square root of 5 is equal to 5 square root of 5. If you want to subtract, it is the same rule. For example, 7 the square root of 10 minus 2 the square root of 10, there it's going to be 7 minus 2, it's going to be 5 square root of 10. This is how we add or subtract. There is only one rule. Okay, the radicands must be the same. Sometimes students are going to make a big mistake, and it is, for example, you have square root of 3 plus, let's say, square root of 3, they are going to say this is going to be square root of 6. And it is not true, because when you add or subtract square roots, we are going to add or subtract the number that you have in front of them. This is about the adding and subtracting. And also we have another important note. You have to know that if there is no number in front of the square root, for example, square root of, let's say, 3 plus 4 square root of 3. Okay, when you want to add it, you can see that there is no number here in front of the first number. Then, if there is no number, it means we have 1. So 1 plus 4, it's going to be 5 square root of 3. Another example, let's say square root of 11 plus square root of 11. None of these square roots have number in front of, none of them has, let's say, number in front of them. It's 1 and 1. 1 plus 1, it is 2 square root of 11. This is all about adding and subtracting, let's say, square root expressions. Then, let's solve some examples here. It says 3 square root 7 plus 2 square root 7. It's quite clear because the radicands are the same, so write the square root of 7. 3 plus 2 is equal 5. So the result is 5 square root of 7. Sometimes instead of number we have variables. 9 square root of y minus 3 square root of y. Okay, we do not care about the variables or the numbers. We just know that they are the same. So it's going to be 9 minus 3, 6 square root of y. Okay, and again, there's no number here. It's 1. 1 plus 3, it is 4 square root of 5. But sometimes the square roots, the radicands are not the same. For example, here in this example, the 3 times square root of 12, 3 times square root of 12 minus square root of 75. You ask that question, okay, mister, in the beginning of the class you said that the radicals must be the same. But right now, they are not the same. What shall we do? Then we are going to simplify them. We can simplify 12 and also you can simplify 75. If you remember in the previous class, we said that 3 times 12 is going to be 4 times 3 minus 75, it's going to be 25 times 3. So right now here the square root of 4 is 2. But remember, we have 3 in front of it, so multiply. 3 times square root of 4 was 2 times 3 stays under the square root. Then minus. The square root of 25 is 5. 3 stays under the square root. Then if you look at the radicands, they are the same. Then 3 times 2, it's going to be 6 square root of 3 minus 5 square root of 3. The radicands are the same, so we can subtract them. 6 minus 5, it's going to be 1 square root of 3. If you write 1 or do not write it, it's the same. Okay, this is the result. So we've made a mistake here. This is not 4, it's 3. That's why the result is different, but it is 3. I wrote 4 here. It is 3. It's not 6. 6 minus 5 is going to be square root of 3. Next example, we have square root of 32 minus 3 times square root of 8. Again, the radicands are not the same. We have to simplify. 32 is 16 times 2 minus 3 times, okay, 8 is 4 times 2. Then 16 is going to be 4 square root of 2 minus 3 times 4 is going to be 2 and 2 stays under the square root. Then equal 4 square root of 2 minus 3 times 2, 6. Okay, here's 4, I forgot the 4. Then minus 3 times 6 is 6 square root of 2. 4 minus 6, that's going to be negative 2 square root of 2. So this is the results. Here I forgot to write down the 3 here. 3 times 6, then it's going to be 4 square root of 2 minus 6 square root of 2. Then it's going to be negative 2 square root of 2. Okay. Example C, we have square root of 125 plus 3 square root of 20 minus square root of 45. So 125 is 25 times, that's 25 times 5 plus 3 times 20 is 4 times 5. What about 45? 45 is 9 times 5. So the square root of 25 is 5, the square root of 4 is 2, and the square root of 9 is 3. Then the result is going to be 5 square root of 5 plus 3 times 2 square root of 5 minus the square root of 9 is 3 square root of 5. 5 square root of 5 plus 3 times 2 is 6 square root of 5 minus square root of 3 square root of 5. So right now all the radicands are equal. Okay, then we can add and subtract. So 5 plus 6 is equal 11 minus 3, then it's going to be 8. 8 square root of 5. This is about the, let's say, simplifying whether the radicals are not equal. Then we have another type. Then we are going to use distributive rule or formula to simplify. Our question is square root of 3 times square root of 3 minus square root of 5. I'm going to remind you, if there is no operation here, it means we have multiplication. Then inside the parenthesis, the bracket, we have two terms. Then we are going to multiply square root of 3 by the square root of 3 and multiply by the square root of 5. Square root of 3 times square root of 3, it's going to be 3. Why? If you remember, square root of a times square root of a is equal a. So it's equal 3. Positive times negative is negative. Square root of 3 times square root of 5, we are going to write it as the product of one square root. Then 3 minus 3 times 5, then it's going to be 15. The result is 3 minus the square root of 15. Next question. This time we have two parentheses, the product of two parentheses. We have 4 plus square root of 5 multiply 3 minus square root of 5. Okay, so we multiply 4 times 3 is 12. Positive times negative, negative. 4 times square root of 5, it's going to be 4 square root of 5. Please be careful. Do not make that mistake. When you say 4 times square root of 5, it's going to be 4 square root of 5. But sometimes students are going to say it's going to be 4 times 5, then it's going to be square root of 20. It's not true, because we have a number, we multiply by a square root. Then it's going to be 4 square root of 5. We cannot say 4 times 5, then it's going to be the square root of 20. It's not true. In a case, if you have square root of 4 times square root of 5, it's going to be square root of 4 times 5, then square root of 20. In this case, both of them have square root, but a number multiplied by a square root, then write the number with the square root. Okay. So we got 12 minus 4 square root 5. Then for the second one, square root of 5 times 3, it's going to be 3 square root of 5, because positive times positive is become positive. Then finally, positive times negative is negative. Square root of 5 times square root of 5 is equal 5. Square root of a times square root of a is equal a. So we are looking for a like terms. For the like terms, we have 12 with negative 5, and also we have negative 4 with positive 3. Let's start with the numbers. 12 minus negative 5. So 12 minus 5, not negative 5. 12 minus 5, it's going to be 7. Negative 4 square root of 5 plus 3. Negative 4 plus 3. Negative 4 plus 3, it's going to be negative 1. So minus square root of 5. If you write 1 here or do not write it, it's the same. This time we have a parenthesis with power 2, is square. We can write, if you remember, for example, if you have 2 power 2, it's going to be 2 times 2. Or let's say we have 9 power 2 is equal 9 times 9. So here we have square root of 7 minus 5 square, it's going to be it's going to be square root of 7 minus 5 multiply square root of 7 minus 5. We write the expression 2 times. Then let's multiply. Square root of 7 times square root of 7 is equal to 7. Positive times negative, it's going to be negative. Square root of 7 times 5, 5 square root 7. Let's multiply the second part. Negative times positive is negative. 5 times square root of 7, 5 square root of 7. Square root of 7. Negative times negative is positive. Okay. Then 5 times 5 is 25. Then we are looking for the like terms. The like terms are 7 plus 25. Then it's going to be 32. Negative 5 minus 5, it's going to be negative 10 square root of 7. So this is the result, because negative 5 minus 5 is equal negative 10. So negative 10 square root of 7. The last part of this subject is rationalize the denominator. How to rationalize the denominator, or when do we do that? When we have a square root in the denominator. For example, let's say we have 3 over square root of 2. When you have square root in the denominator, then we are going to rationalize it. How to do it? We multiply numerator and denominator by the square root that we have in the denominator. In the denominator, we have the square root of 2. That is why we are going to multiply numerator by square root of 2, denominator by square root of 2. 3 times square root of 2, 3 square root of 2. Square root of 2 times square root of 2, it's going to be 2. Okay, let's solve the first example here. Square root of 7 over square root of 2. Square root of 7 over square root of 2. Because in the denominator we have square root, then we are going to rationalize it. Multiply the square root of 2, square root of 2. Square root of 7 times square root of 2, it's going to be square root of 14. Square root of 2 times square root of 2, it's going to be 2. So this is the result. Next example. We have 1 plus square root of 3 over square root 2 square root of 3. So in the denominator we have square root of 3. So we multiply numerator and denominator by square root of 3. Square root of 3, square root of 3. Then let's multiply it. Because here we have 2 terms, then it's going to be square root of 3 times 1, it's going to be square root of 3, plus square root of 3 times square root of 3, it's going to be 3. Then 2. Square root of 3 times square root of 3, it's going to be 3, and we have multiplication between them. Then it's going to be square root of 3 plus 3 over 6. So this is the result on how to rationalize the fraction. Then we have some ijtimai questions. The first question is square root of 7 plus square root of 5 times square root of 7 minus square root of 5. So let's solve it. Square root of 7 times square root of 7 is equal to 7. Square root of 7 times square root of 5, we have positive times negative is negative. Square root of 7 times square root of 5, it's going to be square root of 35. Because 3 times 5, 7 times 5, it's going to be 75. For the second part, square root of 5 times square root of 7, again, is going to be square root of 35. Because positive times positive is become positive. Then square root of 5 times square root of 5, it's going to be 5. Positive times negative it's going to be negative 5. So we have like terms. What are the like terms? The like terms are negative square root of 35, positive square root of 35. Because they are opposite, then it's going to be 0. The only thing there is 7 minus 5 is equal 2. So the answer is 2. It is D. That is the correct answer. Then question 2. This is question 2. 3 times the square root of 3 times 5 minus square root of 3. 3 times 5, it's going to be 5 square root 3. Positive times negative, negative. Square root of 3 times square root of 3, it is 3. So the answer is 5 square root of 3 minus 3. C is the correct answer. Then for question 4, we have to subtract them, but they are not like terms. The radicands are not the same. So it's going to be 2, 4 times 3 minus 72 is going to be 9 times 3. Okay? Then 2, the square root of 4 is 2 square root of 3 minus the square root of 9 is 3. 3 stays under the square root. 2 times 2 is 4 square root of 3 minus 3 square root of 3. So the radicands are the same. Write down the square root of 3. 4 minus 3 is equal 1. So the answer is square root of 3. So it is A is the correct answer. Question 5. Again, it's the same number. We have 5, and instead of 27, you are going to write 9 times 3 minus 2 times 4 times 3. Okay? Then 9 is going to be 3, 4 is going to be 2. 5 times 3, 15 square root of 3. 2 times 2 is 4 square root of 3. So we have 15 minus 4 is 11 square root of 3. So the answer is C. The answer is C. Then question 4 is 18. The square root of 18 minus 2 square root of 2. We cannot simplify 2 square root of 2, but we can simplify square root of 18. It's going to be 9 times 2 minus 2 square root of 2. 9 is 3. 2 stay under the square root minus 2 square root of 2. 3 square root of 2 minus 2 square root of 2 is going to be square root of 2. The answer is D. Question 8. This question is for the previous year. Okay, most of the students didn't know how to solve it. They, again, as the previous section when you had a square, the students, they thought that this is for geometry, but it's not geometry. We have a trapezoid. It says find the perimeter of the trapezoid. So we have square root of 8, square root of 50, square root of 8, square root of 18. If you want to find the perimeter of the trapezoid, we are going to add all the sides. This side plus that side and plus this side. Then it's going to be square root of 8 plus square root of 50 plus square root of 8 plus square root of 18. Then 8, it's going to be 4 times 2 plus 15 is going to be 25 times 2 plus 8 is 4 times 2 plus 18 is 9 times 2. It's quite easy. 4, it's going to be 2 square root of 2 plus 25 is 5 square root of 2 plus 4 square root of 2, then finally 3 square root of 2. The radicands are the same. We can add all the numbers. 2 plus 5 is 7, plus 2 is 9, plus 3 is 12, square root of 2 centimeter. Okay? So, dear lovely student, this is the last example of this section, and I hope you get benefit from me. Thanks for watching.